Hi there, boys and girls. This is Chapter 12, Lesson 4, and the topic of today's lesson is the shape of data distributions. So when you're looking at a graph of data or a display of data, what can you say about it? The first word that we're going to talk about data is a symmetric distribution. So the word distribution is just talking about your display of data. So if you have a symmetric distribution, the data are evenly distributed on the left and right side, kind of like a line of symmetry or a butterfly. It's the same on both sides if you fold it right down the middle. So this would be data that are evenly distributed or spread out between left and right side. Left and right, I'll abbreviate. So that is, if your distribution is symmetric, it's the same on the left side as it is on the right side. So that's one key classification or way to talk about your data. Is it a symmetric distribution or not? The other thing that we can talk about data is a cluster. Well, you can kind of guess when there's a cluster of kids in the hallway, there's a big group. So that's kind of what it means with your data as well. Several data values grouped together. Okay, that's a cluster. Several data values grouped together. I'll highlight that one orange. So these are keywords over here to describe the distribution of your data. Another word that we can use is gaps. And that means just what it sounds like. If there's a gap in your data, there's a hole, missing data. So there's no data values in a gap. Make that one pink. Okay, gaps. The last thing, we've talked about this one before, is outliers. And outliers, again, are extreme values. So they're way off to one side, extreme values. We'll make that one blue. Okay, another way we can talk about data is a peak in your data. And the peak is the most frequent value. Also known as the mode. Now, some distributions you can tell the peak and some you can't, and we'll talk about that in a little bit. So different color, I'll go green. So these are all key words that we're going to use today to talk about your distribution of data. Next, let's describe a data distribution. Describe this data distribution. Okay, and you should be able to name what this is, but I'm going to should be able to name what kind of data distribution this is. So draw a line, and I'm going to start at 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So This is going to be a line plot or a dot plot. And we're going to put two values at 16. We're going to put one value at 17, two at 18. We're going to put 4 at 22. So 1, 2, 3, 4. We're going to put 1 at 23. And 2 at 24. And 2 at 25. Okay, so now we're going to use these words, and we're going to talk about our data distribution for this line plot or dot plot. And the first thing we can say is that it's not symmetric. There's not a line that I can put in here where I could flip the data and it's exactly the same on the left as it is to the right. So the very first thing we can say is that it's not symmetric. So part of what you're going to be doing today on your assignment is describing a distribution. So that's one thing you can look at your data and say, can you flip it left to right? Is it the same? And if it's not, then you'd say it's not symmetric. I'm going to highlight these the same colors that we used up here. So I could say that this data, if this was our data distribution, the first thing we could say is, well, it's not symmetric. There is a gap between 19 to 21. There's no values at 19, 20, or 21. So that would be called a gap in our data. So I'm going to say that there's a gap between 19 to 21. Now you could also have multiple gaps, more than one gap in your data. This distribution has one. And so I'm going to say that's another way we could describe this distribution. There's a gap there. Clusters. This data, I would say, has two clusters. There's a cluster right here, and there's a cluster of data right here. There's two clumps or clusters of data. So we could say that there's a cluster from 16 to 18, and another cluster 22 to 25. Is there a bunch of data that's grouped together? That's a cluster. And you can have multiple clusters. So there's another way we could describe that data using clusters. This particular distribution, a line plot or dot plot, I can tell the actual data values. Here they are. These X's represent an actual data value. So I know the mode. 22 is the mode because it came up 4 times. And that's also called a peak. So the peak, looking at this distribution, the peak is the tallest point, which is also the mode. That was at 22. And I'm going to put mode over here. Now, other types of data distributions, you can't tell what, think of a histogram. A histogram gives you ranges. 20 to 29, 30 to 39, and it tells you how many values are in that group, but you don't know the actual values like you do with a line plot or a dot plot. So for this one, I could say that there's a peak. There's no outliers. There's no extreme values way off to the left or way off to the right. And that is a good description for this data right here. Not symmetric. There's 2 clusters between 16 and 18, 22 to 25, and then there's a gap from 19 to 21. Also a peak right here, or the mode of 22. Okay, now we're going to look at describing the distribution for a different kind of graph or distribution of data, a box plot. So I'm going to draw a line right here and follow along, and we're going to make a box plot or a box and whisker plot, and it's going to start let's see, we're going to make the first whisker like that. Then we're going to have a box. So this I'm making 2 squares. This one, the center box or rectangle is 4, and then I'm going to come out this way. That whisker also has a length of 2. Okay, so that's our box and whisker plot so far. So down here, I'm going to make label this. I'm going to count 10, 0, 10, 20, 30, 40. Each line I'm counting by 10. 50, 60, 70, 80, 90, and 100. Okay, so box plot or box and whisker plot. Unlike the line plot or dot plot, I don't know the actual data values. I know that the median is 50. Here's the first quartile, second quartile, and here are my whiskers. But I don't know the actual data values. I can look at this and say that it is symmetric, because right here, if I fold across, this whisker is exactly the same as that one, and the rectangle is exactly the same as this rectangle if I fold right on the median. So one thing I could say about this is that it is symmetric, but I can't tell. Looking at this, I don't know what the gaps are, the peaks are, or the clusters, because I don't know what the actual data values are. I don't have my actual data values like I do up here. So if you have a box plot or a box and whisker plot, you cannot tell. I cannot tell gaps, peaks, and clusters. Okay, can't tell them from this graph because it doesn't give me the actual data values. I can say that this is a symmetric distribution. I could fold it right across the middle, so I could say that it is symmetric. Okay, last thing we're going to talk about, tilt the camera a little bit here. Last thing we're going to talk about is deciding which measures of center and which measures of variability to use based on a guide. So the other section we're going to talk about is this. Which measures of center and again, remember measures of center, mean, median, and mode, and which measures of center and measure of variability to use, depending on your data. So this is the guide. The first question you ask is your data symmetric? Okay, so is data distribution symmetric? Question mark. Is your data distribution symmetric? If it is, so then we're going to have 2 branches off to this guide. One this way, one this way. And if the answer is yes, your data is symmetric, what you should use is the mean, and you should, for measure of center, so let's write that down. So the measure of center that you would want to use would be the mean, and the measure of variability that you would want to use would be the mean absolute deviation, and I'm going to abbreviate that MAD, mean absolute deviation. So if your data distribution is symmetric, this is what you should choose right here. So if yes, you're going to want to pick the mean for the measure of center and the mean absolute deviation for your measure of variability. If you look at your data distribution and you ask, is it symmetric, and you say no, it is not symmetric, then the best measures you would pick for your measure of center, you would pick the median. Which is, again, you'd arrange all your data in order and cross out till you get to the very middle. Your measure of variability that you would want to use would be interquartile range. So again, finding your third quartile, your first quartile, and subtracting for the interquartile range. So this is what you would pick. If your data distribution is symmetric, you're going to pick measure of center mean, measure of variability mean absolute deviation. If your distribution is not symmetric, then your best measure of center is the median, and your best measure of variability is interquartile range. So this is what you're going to be practicing today, identifying these characteristics, looking at a data distribution. Sometimes you can tell more if it's a line plot or a dot plot. You'll be able to tell more because you actually have all the data. Box plot, you can't tell as much. You can't say if it's symmetric or not, but you can identify gaps, peaks, and clusters. And a histogram is kind of in the middle. You know the data ranges, but you don't know the actual data values. And then the last thing is working with this question. If you're asked which measures of center and which measure of variation to use, go with this question as a guide. Is your distribution symmetric? Look at your data. Can you fold it and left matches up with right? If yes, you're going to use the mean and the mean absolute deviation as your best descriptors. If you say no, you're going to pick the median and for measure of center, and your interquartile range is your measure of variation. Okay, that is it for lesson 4. I'll see you again soon for lesson 5.